Welcome to the DIY Honda Garage channel. The DTC P2565 indicates an issue with the Turbocharger Wastegate Control Actuator Position Sensor Circuit, specifically signaling high voltage. This diagnostic trouble code, commonly referred to as DTC P2565, relates to the turbocharger assembly, a critical component in enhancing engine performance by regulating the amount of exhaust gas directed to the turbine. The wastegate actuator sensor is integral in controlling the turbo's functionality, ensuring that the turbocharger operates at optimal efficiency. This sensor is typically located near the turbocharger within the engine bay, specifically connected through a 5-pin 5P connector. High voltage readings on this sensor circuit may suggest an electrical malfunction affecting the actuator's response, potentially leading to compromised engine performance, poor fuel efficiency, or even engine damage if not addressed promptly. Understanding the implications of this DTC allows technicians to isolate potential issues effectively. DTC P2565 is confirmed when the Turbocharger Wastegate Control Actuator Position Sensor records a voltage higher than the designated threshold, which is usually set at 4.87 volts. This high voltage condition may prevent the actuator from behaving as intended and can cause performance issues or even damage. It is crucial to understand that the actuator must reliably report to the Powertrain Control Module, PCM, which utilizes this data to adjust the engine's performance. In essence, the actuator allows the turbocharger to maintain boost pressure efficiently, thus directly impacting the vehicle's power output. Diagnosing and interpreting this DTC correctly requires the use of an HDS, Honda Diagnostic system, to monitor signal thresholds and current conditions. Accurate readings will guide the technician in determining whether to confirm the fault or if fluctuations are due to intermittent failures caused by connection issues. Several factors can lead to the activation of DTC P2565. First, corroded or damaged electrical connections to the turbocharger wastegate actuator can interfere with the signal transmission, resulting in false high voltage readings. Secondly, a faulty turbocharger position sensor itself may provide erroneous data, preventing the system from accurately regulating boost levels. Wiring issues, such as shorts or open circuits between the sensor and the PCM, can also contribute to this high voltage condition. Lastly, while less common, a malfunctioning PCM could misinterpret the signals and result in similar errors. It is essential to thoroughly inspect these components to pinpoint the source of the problem. Understanding these causes enables technicians to target their troubleshooting efforts effectively. When the DTC P2565 is present, several symptoms may manifest, indicating potential issues in the vehicle's performance. Drivers may notice poor engine performance, particularly under acceleration, as the turbocharger struggles to deliver optimal boost levels. This situation can lead to increased fuel consumption as the engine compensates for inadequate power. Additionally, the check engine light will typically illuminate, alerting the driver to a problem that needs addressing. Some may even experience turbocharger malfunction, where the expected boost from the turbocharger is not achieved. Recognizing these symptoms early on can prevent further complications and allow for timely repairs. By paying close attention to the vehicle's behavior, drivers can provide crucial information to technicians diagnosing the root cause of the trouble code. The first step in troubleshooting DTC P2565 involves verifying the problem by turning the vehicle to the on mode. Using the Honda Diagnostic system, HDS, you should check the electrical wastegate, EWG voltage, from the lift sensor. You are looking for readings that should not exceed the specified threshold of 4.87 volts. After obtaining the voltage reading, compare it against the established criteria. If the current conditions match the threshold, then the failure is confirmed. and you should proceed to the next troubleshooting step. However, if the voltage is lower than expected, this potential intermittent failure suggests that the system may be operational at that moment. In such a scenario, a thorough inspection of connection points at both the turbocharger and the PCM is warranted, as loose terminals could lead to inconsistent readings. In the second troubleshooting step for DTC P2565, you begin by turning the vehicle to the off lock mode. Disconnect the turbocharger 5P connector to ensure safe handling. Once disconnected, you will connect terminals A and B using a jumper wire. Specifically, terminal A corresponds to turbocharger 5P connector number 3, while terminal B is turbocharger 5P connector number 4. This step effectively bypasses the position sensor temporarily, allowing you to observe how the system reacts without the sensor's input. After making these connections, turn the vehicle back to the on mode. Again, use the HDS to check the EWG voltage. A reading exceeding 4.87 volts implies that the system is not at fault, prompting you to continue troubleshooting. Conversely, if the voltage indicates a failure, replacing the turbocharger may be necessary. For this troubleshooting step, start by turning the vehicle to the off lock mode and carefully remove the jumper wire you installed in the previous step. Now, it's time to assess the voltage condition without the jumper. Turn the vehicle back to the on mode and measure the voltage between two specific test points. The test points correspond to turbocharger 5P connector number 2 and number 3. It's essential to conduct this check while the turbocharger 5P connector remains disconnected. You're ideally looking for a voltage reading around 5.0 volts between these 2 points. If this condition is met, it's a positive indication that the system's integrity remains intact, allowing you to proceed to the next troubleshooting phase. However, should you find a discrepancy in the voltage reading, investigation into the wiring or other components may be warranted. In this step, you will begin by turning the vehicle to the off lock mode once more. To facilitate the next check, jump the SCS system control supply line using the HDS and allow for a wait period of more than 1 minute. This action ensures that any incorrect parameters reset before you examine the system's continuity. After this, disconnect the PCM connector E, 80P, to isolate the circuit. Next, you will check the continuity between test points 1 and 2. Test point 1 corresponds to turbocharger 5P connector number 3, while test point 2 connects to PCM connector E, 80P, number 78. A continuity check in this phase will help determine whether the SG2 wire is functioning correctly. If you confirm satisfactory continuity, it indicates that the wiring is intact, and further inspection of the PCM or related components may be necessary. If continuity fails, it suggests an open circuit in the SG2 wire that requires immediate repair. For the final troubleshooting step, you will once again start by turning the vehicle to the off lock mode. Jump the SCS line with the HDS, awaiting over a minute for system stabilization. Following this, disconnect the PCM connector E, 80P, to facilitate the necessary continuity check. Now, focus on the wiring between test point 1, which corresponds to turbocharger 5P connector number 4, and test point 2, which is PCM connector E, 80P, number 60. This measurement assists in verifying if the DCWGL line is functional. A successful continuity reading indicates that this wire is intact and operating correctly. In case there is no continuity, it highlights an open wire issue that requires appropriate repair to ensure seamless communication between the PCM and the turbocharger. Once rectified, the system can return to proper operational standards. After completing the necessary repairs associated with DTC P2565, it is imperative to verify the effectiveness of the fixes. Start by confirming that all repairs have been accurately conducted and all relevant connections and components are securely installed. Following this, utilize your diagnostic tools to erase the fault codes from the system, effectively clearing any previous alerts related to the turbocharger wastegate control actuator. Once the DTCs are cleared, it's vital to conduct a test drive under varied driving conditions to ensure that the vehicle operates smoothly without logging any new faults. Monitoring the performance of the turbocharger during this drive will help ascertain that ample boost pressure is generated and that the system functions optimally. Successful completion of this verification process will confirm that the repair work has resolved the original issue indicated by DTC P2565. To minimize the risk of encountering DTC P2565 in the future, preventative maintenance is essential. Regularly check electrical connections around the turbocharger and other sensor connectors to detect any early signs of corrosion or looseness that could lead to signal disruptions. Using quality replacement parts during repairs can significantly lower the chances of future occurrences, as substandard components may fail prematurely. Furthermore, maintaining the integrity of all wiring related to the turbocharger wastegate actuator can also preclude potential issues. Regular inspections combined with thorough diagnostics will enhance the longevity of the turbocharger system and ensure optimal performance. A proactive approach to vehicle maintenance empowers drivers to address potential issues before they escalate into larger, costly problems. In conclusion, DTC P2565 serves as a crucial indicator of issues within the turbocharger wastegate control actuator position sensor circuit. Understanding the implications and symptoms of this error code enables technicians to execute targeted troubleshooting effectively. Following a systematic approach, as outlined in the diagnostic steps, ensures that the underlying problems are accurately identified and addressed. Incorporating preventive measures into regular vehicle maintenance helps ensure the longevity and reliability of the turbocharger system. Ultimately, by staying vigilant and employing comprehensive diagnostic practices, technicians can uphold the performance of Honda Civic models from 2016 to 2021, ensuring a seamless driving experience for vehicle owners. Please like and subscribe to the channel. See you next time.